Hi, this question is from GATE 2018, and this question is a multiple choice question, and the question states a quarter wave plate introduces a path difference of lambda by 4 between the two components of polarization parallel and perpendicular to the optic axis. An electromagnetic wave with E equals x cap plus y cap times E naught exponential iota kz minus omega t is incident normally on a quarter wave plate which has its optic axis making an angle 135 degree with the x-axis as shown. So the figure is clearly given, and they are asking the emergent electromagnetic wave would be option A, elliptically polarized, option B, circularly polarized, option C, linearly polarized with polarization as that of incident wave, and option D, linearly polarized but with polarization at 90 degree to that of the incident wave. So let us solve the problem. So given electromagnetic wave E equals sorry x cap plus y cap times E naught exponential iota kz minus omega t. So we can rewrite this thing as x cap E naught x e power I kz minus omega t plus y cap E naught exponential iota kz minus omega t, and this can again be written as E equals ex x cap plus ey cap. So we have written it in the component form. Okay, so the electromagnetic wave is superposition of two mutually perpendicular plane polarized wave. Okay, and the components are, or the both polarized waves are ex, which is a function of z and t, equals e naught e power iota kz minus omega t, and ey zt also equals e naught exponential iota kz minus omega t. Okay, now here the superposition of these pair of waves give linearly polarized wave as the phase difference is, let us say this phase difference as delta equals 0. Okay, so the resultant electric field vector makes an angle theta theta with the x-axis, then we can write easily that the tan of theta will be ey zt by ex zt, and this should be equals to 1 because ex and ey are equal. Okay, and 1 means tan of 45 degrees. This implies that theta equals 45 degrees. Okay. So let me just draw the diagram here. Okay. So this is the x-axis, this is the y-axis, and this thing is the optic axis. Now the optic axis is at an angle of 135 degrees, and that is given. Okay, so first thing we have that the linearly polarized means the resultant electric field. So let us consider this is the resultant electric field. It will make an angle of 45 degrees with the x-axis, and given that this angle is 135 degrees. Okay, so we can say that this angle in between, this angle is a 90 degree. Okay, so we can write thus the electric field of incident wave falls on the quarter wave plate at phi equals 90 degrees. So this angle is phi equals 90 degrees. Okay, so this is a linearly polarized light because tan theta equals to 1. So we know that when a linearly polarized is I have just mentioned as LP, Light is incident on the quarter wave plate with oscillation perpendicular to the optic axis. It emerges out with same polarization. So this makes our correct answer as C. Thank you.